So, 2 weeks ago, we talked about how atoms of elements are represented through different models. Today, we're going to be looking at something called ball and stick models, which shows us how atoms of elements form compounds. So, a lot of the things we'll be discussing this week are going to build off of the topics that we discussed last week. This is going to be the last week of instruction, so make sure you're keeping up with all the lessons and turning in your work each day. That being said, our driving question for today is going to be, what are ball and stick models and how do they illustrate how atoms are chemically bonded? And our objective is to identify the number of atoms of an element in a compound based on the compound's ball and stick model. So just to kind of give you a definition for ball and stick models, more of a formal definition. Ball and stick models are visual representations of compounds and molecules that use ball and stick figures to illustrate chemical bonds. And here we have an example. H2O, of course, we know, we worked on this last week, is a chemical formula. And then to the right there, we can see a ball and stick model for a molecule of water, or H2O. So let's talk about interpreting ball and stick models. In this example, we have sodium chloride, or NaCl, right? The element symbols for sodium and chlorine. This is would be a example of table salt. Now we know table salt's chemical formula is NaCl, like we said, and it's one example that we looked at quite frequently throughout the lessons we've been doing the past couple weeks. Looking at the chemical formula NaCl, we can determine the number of sodium atoms and the number of chlorine atoms. That's what we were working on last week when we were looking at chemical formulas and subscripts. So after the practice we had last week, we know to look at the subscript to determine the number of atoms of each element. We can see that there are no visible numbers after the element symbols. Both sodium and chlorine have one atom in this compound. We know that, again, because there's no number in this chemical formula here, so we just assume that there's one atom of each in the compound. We can see that in the ball and stick model because there's only one ball to represent an atom of each element. If you take a look, you can see that the little green ball there is the chlorine, and then the purple ball is going to be the sodium atom. Ball and stick models often use the sticks in between the ball to represent the way electrons are gained, shared, or lost between these elements. But we're not getting into that just yet. Just keep that in mind as we're moving forward. That being said, we know that this is an ionic bond because it is a compound between a metal and a non-metal, something else that we talked about last week. So let's talk about molecules and ratios, which is what we're going to be talking about this week. So on the left here, we're using what we know about chemical formulas to kind of help us interpret these ball and stick models throughout this week. So it's not necessarily learning something new. We're just kind of revisiting the things that we've already discussed and looking at them in a new way. So many compounds represent substances that form molecules, like water. Water is an example of this. It has molecules when it's in a glass or something like that. But other compounds form a crystal structure, like salt does. The subscripts in the chemical formulas are very important because they tell us the ratio of the elements in each compound. For example, if we're looking at a glass of water, there would be many molecules of water in a single glass. Obviously, it's not just one molecule of water because that would be too small for us to even see because it's just 3 atoms, right? The important thing that we need to know is that for every 2 hydrogen atoms in a glass of water, we have 1 oxygen atom, right? The H2O. That's the ratio. Now, if we look at the model on the right for sodium, which we said is a crystal-like structure, it looks kind of overwhelming because there's a lot of green and blue balls in the model there. But the important thing to notice is that for every green ball, there's 1 blue ball. So the ratio in NaCl, or table salt, is 1:1. That's because in sodium chloride, NaCl, there's always going to be one sodium atom for one chlorine atom. And that's what we call a 1:1 ratio. So today, to help us get a better understanding of this, we're going to be completing IXL E2. I have posted a link to the IXL in today's Schoology folder, so you can click that and follow that. Make sure that you are completing that. It will count towards your participation grade for this week. And if you have any questions or any difficulty, just reach out to me and let me know. Also, remember that Friday is the last day for instruction, Friday, May 29th, which means that you must complete and submit all your assignments by Friday. So if you have any zeros or any outstanding assignments, anything that you missed, let me know and we can work together to get that made up for you. But if you don't let me know and I don't hear from you, then I won't know that you want to make those things up. I will be reaching out to people through Schoology or emailing. So just keep an eye on that, as this is the last week of instruction. So if you have any questions today, let me know. Otherwise, go ahead and complete IXL E2.